Senior Intermediate on counting. Before you continue watching, make sure to subscribe and like. The topics we're going to be covering today are fundamental counting principle, factorial, permutations, and restrictions. So the first thing we're going to cover today is the fundamental counting principle. And what it says is if there's n ways of doing one thing and n ways of doing another, there's n times n ways for doing both things together. And this can apply to more than two things. We can have like n times o, or like n times o times p, and like all like that. So a little example is, let's say I'm going to buy a car. And when I'm going to go to buy the car, there's 5 different brands car companies that I like. There's BMW, Lamborghini, Ferrari, Porsche, and I can't think of another one that I like. Okay, anyways, there's 3 colors for each of those cars. Let's just say white, blue, and black. And then for each of those colors, for each of those cars, there's 2 types I can get it in. There's convertible or it's not convertible. So, and then the question may be asking, how many different types of cars can I get? So this is how we're gonna do it. So there's 5 brands that you can get. So 1, 2, 3, 4, 5. Like, I didn't draw the ones in the middle because it's annoying to draw, but the drawing is just to help you guys understand. So for this one, let's say this one's Lamborghini. There's 3 different colors I can get: dark blue, black, and white. And for the Lamborghini that's dark blue, I can have a convertible or not a convertible. For the Lamborghini that's black, I can have a convertible or not a convertible. For the Lamborghini that's white, I can have a convertible or not a convertible. And the same thing goes for all of them. That's why you do 5 times 3 times 2. Because for this one, there's 5 of these, and each of them have 3. So 5 times 3. But then each of those have 2 of those types. So to figure this out, we're just going to do 5 times 3 times 2, which is equal to 30 different types of cars. So now we're going to move on to factorial. And a bunch of people, like what I've noticed is when I'm teaching someone something and it's about counting, I show them the factorial. Or if the problem has a factorial, they don't know what it is. They're always like, what does that exclamation mark mean? Well, this is what it means. So that's how it looks like, and don't confuse it for an exclamation mark. Is it point? Whatever. Okay, so what it means is if you have n factorial, n being any number, well, any whole number that's positive, you have n times n minus 1 times n minus 2 times all the way up to 1. You can't multiply by 0 or else everything factorial would be 0. So an example of this is 3 factorial. We have 3, which is n, times 3 minus 1, which is 2, all the way up to 1. So 3 times 2 times 1 is 6. So that's 3 factorial. Basically, in other words, you're multiplying all the numbers that's on all the whole positive numbers that's less than it, going all the way up to 1. So 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 3,628,800. So now we're going to move on to permutations. Permutation is a type of arrangement in which order matters. And there's many ways to show it. So there's P of n comma r. N is the total number of things, like all of them. R is if you're taking out some of them and just like putting those ones in order, or how many things you're ordering. And then you can also write it with n up here, p, and then r down here, or n down here, p, and then r down here. And then the formula for finding the number of permutations is n factorial over n minus r factorial. So an example of this is, let's say you're applying to college and you want to visit 6 of them. And you're like, and how many ways can I visit 6 of them? First of all, you have to choose 6 of them. Second of all, you have to order like what college you're going to go first and second, and like that. So for that, you're going to do 10, 6, the permutation of 10 and 6. So that's just 10 factorial over 10 minus 6 factorial, which is 4 factorial, which is equal to 151,200. 151,200. Yeah. And let's say you want to visit all of them. In how many ways can you visit all of them? Well, that's the same thing. There's an order here because you have to decide which one you want to go first, second, and like that. So that's 10 permutation 10. And so it's 10 factorial over 10 minus 10 factorial, which is 0 factorial. And something I forgot to mention earlier is that 0 factorial is equal to 1. So, and 10 factorial over 0 factorial is 10 factorial over 1, which is 3,628,800. So now our last thing is restrictions. And there's two types. There's adjacent and topology. And we're going to start with adjacent. So let's say, for example, we have 6 dog statues and 4 cat statues. And we want to arrange them. But there's a condition. All the dog statues must be next to each other and all the cat statues must be next to each other. And how many ways are there to order? First of all, there's 2 ways to order, like the main order. Are we going to do cat then dog or dog then cat? So that's the 2 there. And then there's 6 factorial ways to order these 6 dog statues. And then 4 factorial comes from the number of ways to order these 4 cat statues. Doing all the math, we get 1,728 ways. The second type of restriction is topology. For example, let's say you have 6 friends and you guys are sitting around a round table. And how many ways are there to sit around that round table? Well, and another condition is if it's A, B, C, D, E, F like this, and then A, B, C, D, E, F like this, they are the same thing. So you might be wondering, how are we going to do this? So what we're going to do is we're going to do 6 factorial because first of all, there's 6 factorial ways to order them. And then there's the thing with seating. There's 6 seats, and A can go A 1, 2, 3, 4, 5, 6. So that means there's 6 of the same. We overcount every single thing 6 times. So we're going to do 6 factorial over 6, which is 120 ways, which is our answer. So our first question of today is, how many ways are there to rearrange the letters in Mississippi without having the same one? So let's first count. Well, this is permutations with repetition. So let's first count how many total things we have. We have 11 factorial. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total things. And then there's 1, 2, 3, 4 I's, 4 S's, and 2 P's. So the good thing about factorials is you can easily simplify. So let's write this out. We get 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And then this is all over. 4 times 3 times 2 times 4 times 3 times 2 times 2. And now we gotta simplify. So what we're gonna do to simplify is let's start off. This 2 and this 2 cancel out. This 3 and this 3 cancel out. This 4 and this 4 cancel out. 5 can't cancel out with anything. This 2 and this 3 cancel out. For this 6, and this 4 and this 8 cancel out to make that 2. Oh wait, and then there's that 2 there. So that cancels. So basically, our answer is going to be 11 times 10 times 9 times 7 times 5. So let's take this step by step. Let's do 11 times 9, which is 99. 7 times 5 is 35. Multiply this with 4. Oh no, that's supposed to be a 5. 9, 49, 7, 27 plus 2, 29, which gives us 5, 6, 3. No, that becomes a 4, 3. So 3, 4, 6, 5 times that extra 0. 3, 4, 6, 5, 0. Which is our answer. So our next and last question is, how many even 5-digit numbers contain each of the digits 1 through 5? So whenever there's something with numbers and like digits, I always start off with drawing a place for each digit. And there's 5 digits, so 5 lines. And so our numbers from 1 through 5 are 1, 2, 3, 4, and 5. And And since there's the last digit has to be even because the entire thing has to be even, we have 2 options to go here. And then we have 4 options to go like for all of these. So 4 options for this, 3 for this, 2 for this, and one last one for this. And just like to re-explain it, our thing has to be even. So that means this last digit has to be even. So that means we only have 2 options to be in this last thing. And then after we take out that, let's say we take out 2, we have 4 options left 4 numbers left to arrange. And there's 4 ways 4 different digits that can be in this. What is this? 10,000s place. And then there's 3 options for this thousands place, 2 for this hundreds, and 1 for this tens. So our answer is 4 times 3 times 2 times 1 times 2, which is equal to 12 times 2 is 24 times another 2 is 8. So in some permutation problems, there's going to be repetition. And for example, you might be asked, how many ways are there to arrange the letters in Ohio? And since there's 2 O's, things might be a little bit tricky. So what you're going to do is the following. So there's n factorial over repetition 1 factorial, repetition 2 factorial, number of repetitions 3 factorial. So you'll understand what I mean when we do the problem. So let's start with Ohio. There's 4 letters, so it's going to be 4 factorial. And then there's 2 O's. So it's just going to be 4 factorial over 2 factorial, which is equal to 12, by the way. And that's it. And permutations might be a bit more complicated. Let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 total letters. And how many P's? There's only 1. How many E's? There's only 1. R's, there's only 1. N's, there's only 1. U, there's only 1. T, there's 2 T's. So 2 factorial. A, there's only 1. I, there's only 1. O, there's only 1. N, there's only 1. S is only 1. But let's just say permutations was spelled weird and had 2 S's. Let's just say that. Then we would do 12 factorial over, and since there's 2 S's, you do 12 factorial over 2 factorial for the T's, and another 2 factorial for the S's. And so that's how you would do it. If there was another S, it would be 3 factorial. But permutations isn't spelled weirdly, so there's not that extra S, and it's just that. And since it's going to be somewhere in the millions, I'm not going to multiply that out. It might even be in the billions. Anyways, I want you guys to do a grammatical for practice. Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!